Okay. The next, refraction through prism. Refraction through prism. You know refraction, when the ray of light travels from one medium to the another medium, the incident ray changes its path. That phenomenon is known as refraction of light. And our topic is refraction through a prism. So first, draw the diagram. Let A, B, C is the prism where AB is one refracting surface, AC is another refracting surface. That means when the ray of light is allowed to fall on the face AB or AC, refraction of light will take place. Let's draw it. ON1, that is the normal to the face AB. ON2, that is normal to the face AC. Then let PQ is the incident ray which is incident with an angle I with the normal. Then this medium is air with refractive index mu1, that is 1 refractive index of air, and the prism that is made up of glass, refractive index let mu2. Again this medium is air, refractive index mu1, that is equals to 1. Due to change in medium air and glass, the incident ray PQ will change its path. Okay, if there is no glass, no prism, then this will be the path of the ray. As there is a prism present, due to change in medium, the refraction will take place and the incident ray will change its path and it will move in this way, QR, where this angle is the first refraction angle R1 and QR is the refracted ray, and this angle R2 which is act as the incident angle for the second phase AC, and again refraction of light will take place, glass to air. That's why this is a denser medium, this is a rarer medium, so the ray of light will move away from the normal. So this will be the final ray which is known as the emergent ray RS, and this angle is E, angle of emergence. Clear? And when you extend the emergent ray in backward direction, here it will intersect the ray PQ, that this is the point T. Here PQ, this is the path of the ray in the absence of the prism. That means if there is no prism, then PQN2, that is the ray, incident ray. As there is a prism present, the refraction of light takes place and the incident ray change its path. So this is the final ray, and when you extend the ray RS in backward direction, you find here an angle. Let this angle is delta. That means you can say the incident ray deviates through an angle delta. So this angle is known as the angle of deviation, delta, angle of deviation. So what is angle of deviation? Angle of deviation is that angle made by the emergent ray with the incident ray. Clear? And the next is we have to find out the formula of angle of deviation del. Clear? So let derive it. Here in the triangle, this is the angle of incidence I. Then you can say this angle will also be equals to I, opposite angle. Then what will be this angle? This angle will be, total is R1, total angle is I, and this one is R1. So this angle will be I minus R1. Clear? And like here, this angle will be E, opposite angle, and this angle will be, total angle is E, and this one is R1. So this angle will be E minus R2. Clear? And here in the triangle TQR, this angle delta, that is the external angle. And you know in mathematics, the external angle is equal to the summation of two internal angles. That means you can write delta, that is equals to I minus R1 plus E minus R2. Clear? So that will be equals to I plus E minus R1 plus R2. Clear? This is the value of angle of deviation. And here in the triangle QRO, one angle is R1, another angle is R2, and the remaining angle is QOR. This angle plus this angle plus this angle. The summation of all the three angles of a triangle is 180 degree. So you can write the angle in triangle QRO. In triangle QRO, R1 plus R2 plus the angle is QOR. QOR, that is equals to 180 degree. That implies the angle QOR, that will be equals to 180 degree minus R1 plus R2. Clear? Again, there is a quadrilateral AQOR. In this quadrilateral, this one is the normal. So this angle will be 90 degree, as this is the normal to the surface. Again, ON2 is normal to the surface. So you can say this one is also the normal. This angle will be 90 degree. Sum of all the four angles of a quadrilateral is 360 degree. So you can write A plus this angle AQO plus ARO plus QOR is 360 degree, and this angle is 90 degree and this angle is 90 degree. So these two are 180, and the remaining two angle A and O will be 180 degree. So we can write the angle QAR, the angle QAR plus QOR, that will be 180 degree. That implies QOR that will be equals to 180 degree minus QAR. So what is QAR? The angle QAR, that is known as the angle of the prism. That is the angle made by the two refracting surface. So this angle QAR, that is known as the angle of prism. So we can write that is equals to 180 degree minus a angle of prism. So when you compare these two equations, the right hand side are you can equate the right hand side as the left hand side are equal. So from these two equations you can write angle A, that is equals to R1 plus R2. That means the angle of prism, that is equals to the summation of angle R1 plus R2. Clear? So put this value into the value of angle of deviation. So the angle of deviation delta, that will be equals to I plus E, and in place of R1 plus R2 you can write A. So that is I plus E minus A. Clear? This is the value of angle of deviation. Angle I, the incident angle, angle E, the emergent angle, minus the angle of prism. Again, you know Snell's law. So what is Snell's law? The ratio of sine of angle of incidence to the sine of angle of refraction, that is equals to the refractive index with respect to the second medium to the first medium. Again, if you apply the Snell's law to the first refracting surface, the angle of incidence is I, the angle of refraction is R1, and the refractive index of first medium mu1, that is 1, and the refractive index of second medium is mu2, that is equals to mu2 for glass, it is 1.5. So apply Snell's law to the first refracting surface. Applying Snell's law to face AB, it will be mu21, that is equals to mu2 divided by mu1, that is equals to sine of angle of incidence, sine I divided by sine of angle of refraction, sine R1. Clear? And for smaller angle, we know for smaller angle sine theta, that is nearly equals to theta. So here the two angles I and R1, you can write sine I as I and sine R1 as R1, and the refractive index of first medium is 1, as this is air. So you can write that implies mu2, that is the refractive index of the glass or second medium, that this is mu, that is equals to I divided by R1. From here you find the value of I, angle of incidence, that is mu R1. Clear? Similarly, if you apply the Snell's law to the second phase AC, what will be the Snell's law for the second phase AC? For the phase AC, the Snell's law will be Here the ray of light that travels from mu2 to mu1. So we have to write mu1 2, that is equals to mu1 divided by mu2. Here the angle of incidence is R1, the angle of emergence, that is E. So this will be sine R2 divided by sine E. Again, for smaller angle sine theta, that is nearly equals to theta. So in place of sine R2 you can write R2, and in place of sine E you can write E. That implies the refractive index of the medium air, that is 1. So in place of mu1 you can write 1. So this will be 1 divided by mu refractive index of glass or prism, that is equals to R2 divided by E. Here you can write the value of E, that is equals to mu R2. Clear? This is the value of angle of incidence I, that is angle of emergence E. And you have to put these two values into this equation. Clear? Now, putting the values of I and E into the equation of angle of deviation, it will be delta, that is equals to I, the value of I is mu R1, the value of E, that is mu R2, and A minus A. So that is equals to, taking mu common, this will be R1 plus R2 minus A. What is R1 plus R2? R1 plus R2, that is equals to A, the angle of prism. So this will be mu A minus A. Taking A common, that implies the angle of deviation delta, that will be mu minus 1 into A. Clear? This is the equation for angle of deviation, where mu, that is the refractive index of the material in which the prism is made, and A is the angle of prism. Clear? So this is the equation for angle of deviation. Next, we have to find out angle of minimum deviation and angle of maximum deviation. Clear? So when this angle will be minimum, in practical class we will perform this. This is here the angle of incidence is I. When we change the angle of incidence, you will find various value of angle of deviation. Clear? And when first we have to increase the angle of incidence. When we increase the angle of incidence, you can observe first the angle of deviation will decrease and it will attain certain minimum value. Then again it will increase. So if we plot a graph between the angle of incidence and angle of deviation, then it will be like this. Clear? Along x-axis we will take angle of incidence I, and along y-axis we have to take angle of deviation delta. First you can observe from the practical class. First, that this is for angle of incidence, this is the angle of deviation. When you further increase the angle of incidence, that means if this is the first angle of incidence, this is the angle of deviation from the graph. If you further increase the angle of incidence, you can observe the angle of deviation decreases. That means by increasing the angle of incidence, the angle of deviation decreases. Again, if you further increase the angle of incidence, the angle of deviation will decrease. After attaining certain minimum value with increase in angle of incidence, the angle of deviation again increases. Clear? That means for this value, with increase in angle of incidence, the angle of deviation will increase. If you join all the points, it will be like this. Clear? So the minimum value, that is known as angle of minimum deviation. And when you find the angle of minimum deviation, at the angle of minimum deviation you can find the angle of incidence I, that is equal to the angle of emergence. So we have to derive, we will derive this one now, how I is equals to E. Clear? So when I is equals to E, also R1 will be equals to R2. We will derive it. R1 is equals to R2. Clear? Derive. Okay. From here, from the equation delta, that is equals to I plus E minus A. This is the equation for angle of deviation. Yes or no? Yes. Then I can write like this, that is root I square plus root E square minus 2 root I E plus 2 root I E minus A. Root I square is I, root E square is E. This is minus, this is plus. They will be cancelled, and this will be I plus E minus A. Clear? Then this will be root I minus root E square plus 2 root I E minus A. And this is the case for minimum deviation. The angle of deviation will be minimum. Here the minimum value, for minimum value we can take, this one is 0, del m, at del m you can take this one, that is equals to 0, that is a root I minus root E square minimum value, this is the minimum value. So we can write that implies root I minus root E, that is equals to 0, that implies root I is equals to root E, that implies I is equals to E. Clear? So at angle of minimum deviation, the angle of incidence will be equals to the angle of emergence. Clear? And R1 will be equals to R2. And you can observe when I is equals to E, for minimum deviation, the refracted ray QR will be parallel to BC. That is at minimum deviation. The refracted ray QR, that will be parallel to the base of the prism BC for minimum deviation. And for maximum deviation, if you take from the graph, this is for maximum deviation, you can find two value of same maximum deviation for different value of I, that is I1 and I2. That means you can find same value of angle of deviation, maximum deviation for two different value of angle of incidence. Clear? But angle of minimum is one value at a particular value where I is equals to E and R1 is equals to R2. Clear? So angle of minimum deviation, this is for deviation, angle of deviation, then angle of minimum deviation. Angle of minimum deviation, here angle of minimum deviation, for minimum deviation, for minimum deviation from this equation, a is equals to r1 plus r2, and at minimum deviation r1 is equals to r2. Let this is r, so that is 2r. That implies the value of r will be a divided by 2. Clear? And from this equation, delta, that is I plus E minus A. Again, at angle of minimum deviation, I is equals to E. So we can write in place of I in place of E. So that is angle of minimum deviation, I plus I minus A. That implies A del M, that is equals to 2I minus A. That implies 2I is equals to A plus delta M. That implies I is equals to A plus delta M divided by 2. So this is the angle of incidence. Clear? For minimum deviation. And if we apply Snell's law, what is Snell's law? Mu 2 1, that is equals to sin I divided by sin R. So the first medium is air, second medium is glass. So we can write that is mu, refractive index of the glass with respect to air. Refractive index of air is 1, so this will be mu, refractive index of the material of prism. That is equals to, what is the value of I? This one. So in place of I, you can write this value. So that is sin A plus delta M divided by 2, whole divided by sin, what is the value of R? At minimum deviation, A by 2. So this is A divided by 2. Clear? This one the formula which is known as Prism formula. By using this formula, you can find out the refractive index of the material. Clear? Where A, that is the angle of the prism. You can measure the angle of prism, del M, angle of minimum deviation. The formula to find out the angle of minimum deviation is this one. So by using this formula, you can calculate the refractive index of the material of the prism. Clear? You have to remember this formula. And for thin prism, the formula will be for thin prism, for smaller angle, sin theta, that is equals to theta. So here you can write the refractive index mu, that will be, in place of sin theta, you can write only theta for smaller angle, as this is a thin prism. So this will be A plus delta M divided by 2, whole divided by A divided by 2. So that is equals to, that implies